Right. So last time we started discussing database design. So the logical design versus physical designs. We are in the logical design and we are more concentrating on logical design. Physical design is all about customizing your design for a specific database technology. Okay. Right. So we discuss how to represent entities. We represent entities using tables or relations. And also we look at some concepts related to table, fields, data types, primary key, records, so tuples. Okay. Now, what is attribute of domain, cardinality of the domain, and also degree of relation. Okay. That is how many attributes are there, cardinality of a relation, how many records are there. The order of records is not important when it comes to relational databases. And what is meant by null value? If a value is not there, we call it null value. Primary key and related concepts we discuss. What is candidate key? What is super key? What is primary key? What is alternate keys? Simple key versus composite primary key. Surrogated primary key versus domain primary key or business primary key. Right. So we have done all these things. So then we look at how to map special type of attributes. Of course, normally attribute will be a field, but there are special cases where we must not map derived attributes because those things we can derive from in programming level. Then if it is a composite attribute, we only map sub attributes, right? Sub attributes. So then if you have multi-valued attribute, we model it as one-to-many relationship. Okay, right. So then we moved on to relationships. So relationships is a logical connection between entities or tables or relations. How do you create relationships using foreign key? So what is a foreign key? Field in a table which is mapped to the primary key of the related table. Okay. So that is called foreign key. So the purpose of foreign key is create relationships. Okay. Right. So again we look at the two concepts, degree of relationship and multiplicity of a relationship. So degree is how many entities or tables are involved in the relationship. It can be unary, binary, or ternary. Multiplicity is whether it's one to one, one to many, or many to many. Okay. So there can be any combination. Unary one to one, unary one to many, unary many to many, binary one to one, binary one to many, binary many to many, and so on. Okay. Right. So we discuss all those things and we discuss how to uh, build those things. Okay. How to build those things. Today we are going to do it as a practical exercise. Okay. So binary one to one, binary one to many, binary many to many. How to design and build those things. And so then unary also one to many, many to many. And one example for ternary also we are going to do. Okay. So then we are pretty much done with the relationships. Okay. Right. So let's do it again with access today also because access is easier to work with and understand the concept without much of a technical issues. Okay. Right. So last time I use access again. Okay. Uh, but we just created a table. Right. So today we are going to create some relationships as well. Then we have already database, right? Right. So last time we created a table with just one table called employee, and we added some data. We added some data and a primary key, but no relationship yet. So let's take one by one. We'll start with binary relationships. right? This is very serious stuff. So if you have any doubt, you need to ask then and there. You can talk or you can put it into the Zoom chat. Right. So this is our employee table. So we'll start with binary one-to-many relationship because that is the easiest to understand. So let's assume employee has one department at a time or employee work for one department at a time. But obviously department can have many employees. So that is one to many at a time. Okay. So we only keep track of who is the current manager, not historical things. Okay. If historical things are kept, it become many to many because then one person may be in different departments over the time. But let's say we only keep track of the employee's current uh, department. Okay. So that it restrict to one to many. Okay. Right. So it's something like this. So we have employee work for one department, but department can have many employees. Okay. Right. So already we have the employee table. Let's create a department table. Okay. Department table. Uh, First we need the tables, right? Create. You can do it parallelly also if you can. Create table. So save so that you can give name. So let's say uh, department department. So then I will give add some fields. So employee, we call it employee ID. We'll use the same syntax, design view, and I'll call it department ID. Auto number is easier because then I don't need to enter value. Uh, Remember, name is a keyword in Access. Otherwise, name is perfectly valid word, but not in Access. So therefore, I call it dname. Dname. I can go for short text or something. Maybe just one more field, maybe location or something, just to make it a little bit uh, interesting. Right. So now I have the department table, and by default, it has access as selected department ID as the primary key. Right. Department ID as the primary key. That I don't want to change because I'm happy with that. Right. So now I have the two tables. So how to create a relationship, one-to-many relationship? Add the foreign key to the many site. So in our case, what is the many site? Many site is employee. So therefore, you need to add the foreign key to the employee table. Okay. So therefore, I'll go to the employee table, open it in design view. So far, we have employee ID, employee name, salary, and date of birth, which are related to employee. So let's add the foreign key. Remember, the foreign key must go into the many site if it is one to many. And you can give it any name, but I prefer to give the same name as the primary key of the other table so that by look of it, I know that this is probably the foreign key for this table. But it can be anything because we are going to map it. Okay. Right. So I'll call it department ID. Just the same name we use for the primary key of the other table. But make sure your data type is compatible. So in department table, it is auto number. Here you can't make it auto number because you need to assign a value by yourself, but don't make it text or something because there it is a number. So let's make it a number, right? So now I have added the field, but still Access doesn't know that this is your foreign key. Just because the name is same, it doesn't assume that it is a foreign key. So then you need to close all your tables, close your tables without closing. Don't go to the design view because you will get errors. So then go to database tools. Then there's something for relationships. So by this time, you must have already added the field, but still it is not your foreign key. Click on the relationships. Okay. And then you can see the two tables. Depending on your access version, this will be slightly different, but always you will have this option. So then add those. You can select one and say add selection. Don't add twice. Right. Now I have the two tables. Now remember, this is what I want to make it my foreign key. Still, this is not the foreign key. This is just a field that happen to be the same name as this primary key, but name can be even anything. So now you want to tell access that this is the foreign key for this particular relationship. How to do that? Now you can clearly see these are the two primary keys. Drag the primary key of the one side and drag it. Drag means that you click it and don't release the key. Click, normal click in the mouse. Drag it and when it is in the department ID field or the foreign key field of the employee table, only you release it. Now I release my mouse click. Now there's pop-up. It has picked the two fields and make sure, and it says one to many. It has identified that this is possibly one to many relationship. Yes, correct. Just tick enforce referential integrity, right? And say create. Now you can see it is a one-to-many relationship. In access rather than n, access use infinity sign to denote many. That is access way of telling n. Okay, so that is fine. And this side is one. So it's a one-to-many relationship. Now only it's a one-to-many relationship. Okay. So add the foreign key to the many side, drag the primary key of the one side into the your proposed foreign key field and drop it. And enforce referential integrity. I will explain what is meant by referential integrity later. Now I have the one-to-many relationship. Okay. Right. Now if you want, you can close it. Yes, save. So let's add some data because still we don't have any departments. So I'll call this H, say FIN, say Colombo. Uh, let's say HR, say Candy. Let's just add one more, say engineering, say Jaffna. Right, so now I have three departments. If you want, you can add more departments. And I will save it. Now I have three departments, and obviously I have three employees. Let's add one more employee also. I don't need to add employee ID because it's auto number. Say Bikum, say 145,000. Some weird date I will add as the date of birth. Okay. Right. So now I have set of data. Now only thing is my department ID field is empty. Right. My department ID field is empty. Either I can keep it null. Okay. Or I need to add valid value. Right. Valid value. Valid value means valid department ID. So valid department IDs are 1, 2, 3. That is called referential integrity constraint. Referential integrity constraint says what? Your foreign key field must be a valid value or null. So what are the valid values in this case? Because we have only 1, 2, 3 as department IDs. So if you add something else, you will get error. Okay. Now let's add some valid values. Say 1. This guy is also from department 1. Maybe this guy is from department 2. Maybe this guy is from department 3. Now I should be able to save it. You can see, no issue. But if I add something like 4, there's no department called 4, and try to save it, you will get error. You will get error because referential integrity is violated. Right? But if you want, you can keep it blank. That is fine. Right? So referential integrity constraint says your foreign key field must have valid value or null, but no invalid value. Okay. And again, make it true because true is valid. And you can see different employees can have the same department ID. That is fine because one employee work for one department can have many employees. That is for one to many. Is it clear? because this is super important for exam also. So this is how you create one-to-many relationship. So how to add one-to-many binary relationship? Add a foreign key to the many site and map to the primary key of the, or when we say foreign key, obviously it must be mapped to the primary key, right? But you must add it to the many side. You can't just randomly decide which table having your foreign key. In one-to-many, your foreign key must be in the many table. In this case, employee table. Okay. Now, obviously, one employee, you can enter only one department ID, but same department ID can be there for many employees. So therefore, it is effectively one-to-many. Is it clear? If it is clear, we can go into the one-to-one and many-to-many. Okay. Right. So now we have a one-to-many relationship, one-to-many binary relationship. Right. So let's discuss one-to-one relationship. So one-to-one relationship means what? We discussed it last time also. So one-to-one relationship is one element in A is mapped to one element of B, and one element of B is mapped to one element of A, like husband and wife, country and president. Okay. So how to map binary one-to-one relationship? So let's first introduce a one-to-one relationship to our database. Let's say we have another table called spouse. Spouse. Employee can have one spouse. Spouse means husband or wife. Spouse can be connected to only one employee. So remember, spouse is in our case weak entity. Not a major concept for our company, but we need to keep track of spouse. Maybe because we want to manage their insurance claims. So we must know who's the spouse of a particular employee. So then this is definitely one-to-one, right? Because employee can't have many spouse. A spouse can't be a particular spouse can't be a spouse of a more than one employees. So this must be one-to-one. Okay. Right. Let's first add the spouse table and we'll come back later. Create table. Then of course you can think of any other examples. Okay. It's your imagination and your awareness about businesses and so on. I'll call it spouse. I'll go to the design view. I'll call this spouse ID. Now remember, this is a weak entity. So therefore, you don't need a primary key of your own. Weak entities you don't need, but if you want, you can have it. Right? Or else you can use the primary key of the strong entity as your primary key of your weak entity. Those are the two options. Okay. Those are the two options. But always the strong entity's primary key must be in the weak entity. So I will use the second approach where I will have the spouse employee ID, but as a foreign key. I will have this machine generated spouse ID. Right. I'll call this employee ID. Okay. Let's first set spouse name, his name. Let's call it short text. Now I will add our foreign key because we must know to which employee the spouse related to. Right. This is going to be my foreign key. Right. Employee ID. And remember, it's a primary key in the other table. So therefore, we will make it number. Okay. So by default, this access has taken spouse ID as primary key. I'm happy with that. Auto number is also I'm happy. But this time I can't just make it employee ID as this is because then it will be one-to-many, just like employee and department. So then employee can have many spouses because many spouses will have the same employee ID. So then it is not one to one, it is one to many. So how to prevent that and make it one to one? Make sure your foreign key is unique field. So that which we did not do for the one to many. So unique means same value can't be added to multiple records for the employee ID field. So it depends on how which database you are using. But in Access, this is how you make it. Microsoft Access. Just select that field. Then there's a property window. You can see when I select different fields, that window change. So just select your foreign key field, employee ID. So then there's something called uh, index of, right? Index of. So there it's a drop down. There you select no, yes, no duplicate. By default, it is yes, duplicate, okay, but select yes, no duplicate. No duplicate means this field cannot have duplicate value, or this must be a unique field. So that 10 force, it is one to one. So this is how you make it one to one. Okay. Yes, no duplicate. Oh, we in general we call it, we make that field unique field. Right. Now you can close it. When you close it, it will ask you to save it. That is fine. Now I have the required fields, but still I have not made this my foreign key, because you can make it foreign key going to the database tools. Right. Right. So remember, when you go to the database tools, make sure you close all the tables. I'll go to the relationships now. Now you can see spouse is there because we newly added, but it is not in our main window. You need to add it. Select spouse, right, and say add selected table. Right. I will take spouse to this side because I'm going to create the relationship between employee and spouse. Now this, I'm going to make this my foreign key. Remember, this is a unique field. Now this is going to be my foreign key. How to create a relationship? Drag the primary key and drop it into the foreign key. Right. So make sure you click it and hold. Right. I have click it and hold. I took the cursor to the employee ID of the spouse table. Now I will release. Now you can see it has identified it as one to one. Earlier it identified as one to many. But this time one to one, because we have already made the employee ID unique field, right? No duplicate field. So therefore, Access has identified that, okay, this should be one to one. And again, tick enforce referential integrity so that you will have only valid employee IDs for the spouses. Then say create. Oh, you can see that it is one to one. So what make it one to one rather than one to many? Because we have already made this unique field. Now our table database has one to one relationship and one to many relationship. Let's close it. Yes, save it. Uh, and let's add some records. So let's say this is, I'm not just comparing male, female. So therefore I just call it SP1, SP2. Okay. SP1. Let's say SP1 is the spouse of employee 2. Say this guy. Okay, let's call spouse 1. Right. So then spouse 2. I'll call this is the spouse of employee 1. Maybe just one. Spouse 3. Let's assume this is the spouse of employee 4. So that means employee 3 is not married or whatever. Okay. Right. I can say. I can say. But this time I can't have the same value twice. Remember, employee ID in my spouse table is now unique. So if I try to save this with 1, because 1 is already there, and save it, I will get error. You can see big error message. Because we have make it unique. Why did you make it unique? Because we want to make it one-to-one relationship. So therefore, I'll make it again for something. Right. So now we have one-to-many relationship between employee and department. Add the foreign key to the many site. One-to-one relationship. Add the foreign key to the weak table and make it unique. Or you can map between primary key to primary key, but I just use the second approach. Any questions? Because this is very serious stuff. This is all about understanding, clarify your doubts. This is not like when the exams are nearing, you just remember it. No, it doesn't work that way. That is why keep asking, checking whether you have understood it. Okay. Right. So if you have no questions, we can move on to the many to many. Binary many to many. So remember, many to many means one instance of A is mapped to many instance of B, and one instance of B is mapped to many instance of A, M to N. Like student can register for many courses, course can have many students. Okay, many to many. So many to many relationships are not very frequent, but there are. So let's introduce many to many relationship to our database because I want to use single database to explain all three. Let's say an employee can work for many departments. Sorry, employee can work for many projects. Project can have many employees. Okay. So that means employee can work for many projects. That means at a time, employee can be assigned to multiple projects. But at the same time, obviously project can have many employees, but this is not like department. So department, we assume that at a time, employee belong to one department. This time we really relax that just to make it many to many. First, let's create our project table. Right? Project table. Create table, save project, and I will go to the design view. Right. So let's have the project ID. I always follow a convention so that my life is very simple. Maybe P name, project name, short text. Yeah, maybe that's enough. Project ID, project name. Project name is a short text. Okay, so let's add few projects also. And project ID is my primary key. Project ID is auto number. So therefore I'll call it PR, say project one, project two, project three or something. Right, this is project three. This is project two. Right, I have three projects also. I'll save it. Now how to model that we have project can have many employees, employee can work for many projects. You may think of a solution. You may think of a solution. Ideally, I should give you about 10 minutes to think. If it is a school or something, I will definitely give that time. But unfortunately, this is an extra class. So therefore, I can't give you much time. Okay. So that is why you are supposed to read the notes and come to clarify the doubts. Okay. Right. So therefore, I will not give you time for you to think because you should have read the note and thought about it. Okay. But if you have read the note, of course, you know the solution also now. That is a different story. That is fine. This is how you do it. If it is many to many, we need to use another table. There's no other solution. Of course, without introducing another table, if we can solve this problem, that is super. But there's no such solution currently in relational theory. So if you feel like you have a different solution, simpler solution, of course you can talk. right? So that I can explain why that solution is not going to work, right? So this is the approach, the best approach or the practical approach. If you have one to many, that means we have this kind of a relationship, M to N. So this is requirement, project, employee, employee, project. But this is how the design or this is how the solution comes. You introduce another table, we call it connecting table, and then map it as two one-to-many relationships, where many side is the connecting table. So you introduce a new table and then map it to the other two tables. So that those are one-to-many relationships where the many side is connecting table. You can see when I explain something, I make it very precise. So that is what is expectation, right? As engineers, software developers, be very precise. So don't give vague answers. That means you're not very specific, you're not very sharp, you're not very serious. So we need serious, responsible, sharp people to take up more challenging jobs like engineering, medicine, okay, entrepreneurs, right? So what is the solution? Introduce another table, third table, we call it connecting table, and then map it as two one-to-many relationships where the many side is the connecting table. Perfect answer. So when you give an answer, someone must say, okay, that's a perfect answer. There's nothing missing, nothing less, nothing more. Right. So this is my say employee table. This is my project table. So you can give any name to this. So I prefer to combine these two names because this is my connecting table, say employee project or something. Then make it as one-to-many. How to create one-to-many relationship? Add the foreign key to the many site. So therefore there will be one foreign key for this relationship here, another foreign key for this relationship. And then you can make the combination of these foreign keys or the composition of these two foreign keys as your primary key or your composite primary key. That is a normal approach. Simple as that. So then how do you, now do you have the full answer? How to design one-to-many relation, many-to-many relationship? Something like this. M to N. Introduce a connecting table and make two one-to-many relationships where the many side is the connecting table that effectively create this many-to-many relationship. So how do you prove that this effectively create the many-to-many relationship? I can show you that now I can enter data to preserve this many-to-many relationship. Okay, right. So now we have the project table and employee table, but we don't have the connecting table, right? So let's add a connecting table. I create table, save. I will use my own convention, not my own convention. This is a very popular convention where we combine the two tables names. Okay, let's say uh, employee project, because this is the connecting table for employee project many to many relationship. But you can give any name you want. Okay, right. So then I will open it in design view. Design. Now I am not going to use this auto-generated primary key because this is special table, connecting tables. Okay. So now I need the two foreign keys, right? Because this is the many site. So one is connected to employee. So therefore I'll take employee ID as my name as a convention. That will be my first foreign key. Other ones I will call it project ID because that one-to-one relationship is related to the project table. But now I'm not going for the auto number because these are foreign keys as well. So therefore I'll just go for both numbers. Numbers. And also I'm going to make this combination as my primary key, not single field because single field is not good enough. Single field can will not be unique, but this combination must be unique. So now you need to select first one and then control, select the next one. Don't release the control and right click and say primary key. So then you will find that the key symbol is in both fields. That is how you mark a foreign key, composite primary key in access. Right, composite primary key in access. Okay, now I have composite primary key, but at the same time, these are the two foreign keys. Still, we have not marked it as foreign key. And if you need any other field here, you can add it if it makes sense. Uh, so what kind of fields will may come here? So remember we discussed about, now this super important, I'm now discussing the most important part of the designing. Okay. Remember we discussed that in analysis, you can have, say this is many to many, like employee, project. You can have identifier and attributes here. You can have identifier and attributes here. So those attributes go to the project table, these attributes go to the employee table. And if it is many to many, there's a possibility that there are some attributes here. Very rarely you have attributes here, right? But if it is many to many, yes. Those attributes, why we model it here? Because those attributes are not directly related to this and also not directly related to this. For example, employee name, date of birth, salary here, project name, project location here. But what about number of hours that employee work for a particular project? Now you can see number of hours that employee work for a particular project. So that you can't put it here or there because it's related to both the employee and project. So that kind of things like number of hours worked, those attributes will come here and those are going to end up in now connecting table as well. Connecting table. So that now we are mapping analysis to design. Right? So that is the whole purpose of this topic. Now I can add, if you have such attribute, this is the place to add it. I'll call it number of hours work. Remember, this is not total number of hours a particular employee has worked. No, this is the number of hours a particular employee has worked for a particular project. So therefore, I will call it number, right? Because it's a number. So if you have any such field which is related to both tables, this is the place to add it. Not the employee table or project table. Is it clear? Now I have the composite primary key. Still, I don't have the two foreign keys. So when I add the foreign keys, I'm done with the many-to-many relationship. So let's close. Go to the database tools, relationships. Right now my project table is there. Let's first add it. And my connecting table, employee project is there. Let's add it that also. Now I'm going to create these two one-to-many relationships, which is going to build my many-to-many relationship. So I'll add the first one. Remember, this is many site. So therefore, foreign key is this one. It is mapped to this primary key, employee ID. And here I call it employee ID also. So then this is the primary key. I will drag it and drop it to the employee ID. Drag and drop. Enforce referential integrity. And it has identified it as one-to-many. Yes, this is one-to-many. And this is my other foreign key, project ID, which create one-to-many relationship with project. So again, click and drag the project ID from project table and put it into the project ID field in the connecting table and release. Enforce referential integrity, it has identified it as one-to-many and create. Now I have two one-to-many relationships. So these two one-to-many relationships has effectively made this many-to-many relationship. There's no way you can directly create a many-to-many relationship. So the solution is create those two one-to-many relationships. And each many side is the connecting table. Right? Any question? Now you know how to design one-to-many relationships, one-to-one relationships, and not only that, many-to-many relationships. This is super important for your confidence about the rest of this topic. because database questions are not easy. Now we are into the serious stuff, database programming, right? Already we have covered the networking, other serious stuff, web development, okay, some serious stuff, because now we are in the second half of the syllabus. Right? Any questions? Anything that you have doubts? Anything you want more information? Anything you want to know why? Because remember, why is the most beautiful word, right? Okay. Now, if someone asks how to create one-to-many relationship, one-to-one relationship, many-to-many relationship, do you have the perfect answers, perfect explanation? This is how you do it. If it is binary relationship, okay. So let's add some data. We need to close. Let's add some projects we have added. Employees we already have 1 to 4 and projects 1 to 3. So let's say employee 1 has worked for project 1, say 5 hours. You can see. Again, employee 1 has worked for project 3, say 10 hours. So employee 1 has worked for 2 projects. Let's say employee 2 has worked for project 1 3 hours. That is possible, right? Maybe employee 2 has worked for project 2 8 hours. Maybe the same employee has worked for uh, project say 3 also, say 7 hours. Maybe employee 3 has worked for project 3 10 hours. Okay. So now we have many to many, because you can see that one employee work for many projects and same project has many employees and so on. Okay, and so on. Right. So now we have our database relationships, and also we have set of data as well. Right. So this is how you design binary relationships. It's all done using different techniques. One to many, foreign key goes to the many side. One to one, add the foreign key if it is a weak table to the weak table, weak entity, and make it unique. Otherwise, you can add it to any side. Many to many, you need to introduce a connecting table and model it as to one to many relationships. Okay, right. So remember, we have 3 layers, right? In the very first day, I explained you that there's ANSI database architecture, 3 layer. So this is external layer or user layer. This is conceptual layer or logical layer, internal layer or physical layer. So we are not interested in this layer because this is handled by your database. So this is your data files and index files, because ultimately this data is saved in a file, right? Files. So we are not interested here because this is more related to physical design. Physical designing, we don't care much in your A-level ICT, right? What are the different type of files and so on. Okay. But what we are working here is conceptual or logical layer. What are the concepts in logical layer? Conceptual layer, tables or relations and relationships plus relationships. Okay, these are relations and these are relationships. So I told you, software developers, designers, we are interested in this layer because we don't like to get to the complexity of this layer much, because this layer is easier and more practical to work. But this is for designers, developers, IT professionals. But end users, they don't like this. They don't like to see our data like this. Actually, they won't understand it also. And also they don't like to come and enter data like this. They need to say, okay, this is like Excel sheet, right? So then we will use Excel sheet rather than your database. What they like is some UI. So they like to enter data using forms. They like to see the results in reports. That is what they're interested. So that is a end user layer or the external layer. Okay, user layer or the external layer. So let's create few of those artifacts also so that you will feel like this is a now application. Of course, you need to code these in serious applications. That is why you have the programming subject, web development subject. But this is just if you want to generate a quick solution, not a serious solution, but a quick and dirty solution. So why I call it quick, because I can generate those things within 30 seconds. Dirty means it may not be the perfect. Sometimes some unnecessary fields are there. Right. So if you want the fine-tuned solution, you need to code it using Java, Python, Web, HTML, CSS. Okay. So let's generate that quick candidate solution, because you can get a feeling of how an application looks. Because I told you, designing the database is very, very, very critical part. A lot of people, they don't take this serious. They think that developing the system is the serious stuff, the UI and so on. No, if you mess your database design, right, you will never ever be able to save your data proper way. You may save some data, but they are not related, duplicated. It can be a mess. So that is why database design is super important. For example, if you go for a degree level, it's computer science, IT, you have database subject at least for 2 semesters. Programming for 2 semesters, database for 2 semesters. Because database is as important as programming. Okay. But here we are going to just generate UI quick and fast, quick and dirty solution. Okay. Right. This is not supported by most of the tools, but Access supported. That is one of the reason I pick Access to do this session. Okay. But later we will use MySQL when we go into the SQL. Right. So select each and every table. Let's first select department and say create form. It will generate the UI, not a perfect UI, but somewhat good UI, right? So that your employees, your users will prefer to use this. Okay. So then when you close on it, will ask you to save it. Just give the same name because it is saved as a form, not as a table. Okay. You can see it is coming. This is a department form. We will look at those later. Then select employee table, create form. And I will close it so that I can give it the name and save. Then employee project, that is another form, simple one, save it. I told you I can generate this within 30 seconds. Project, create, form, save. So those are saved under forms. Therefore, I can give the same name also. Spouse, create forms. These are not perfect UI. That is why I told you quick and dirty solutions. Right. Make sure you close it. Otherwise, you will not be able to edit data. Right. After save, again you open it. So let's start with employee because that is our main concept, right? So here you can see this is my first employee, employee ID 1, Nimal, salary is 100,000. This is the date of birth. Anyway, it's just crazy data I added. And this is the department ID 1. And not only that, uh, Access has showed some more information like Nimal has worked for two projects. Project 1, 5 hours. Project 3, 30 hours, 10 hours. So that is handy, right? So if you develop also, maybe your users will see, we want to see how many hours a particular employee has worked. Each and every project, total number of hours. And here you have the next. Next. Okay. So then you can see the employee two, Nimali. She has worked for 3 projects. So there's the third employee. He has worked for 1 project. So the next employee has not worked for any of the project, but his other details are there. So that is my employee UI, right? Generated by Access. And if you develop a system, you may also like to include some of these features. So mostly this is what you need, right? So then what about department? That is anyway simple. So that I can see the department one, finance, location Colombo, and these are the employees. That is handy, right? So when I go to the department, I can see who are the employees and even their salaries and so on. If I go to the next department to HR, so 2 employees. So this department has no employees yet, right? No employees yet, right? So that is my department 4. So similarly, you can look at the project form, which and each project, how many employees are working for that project and how many hours they have worked. That is also very handy. So you can get an idea about how the software is developed. Okay, by doing this, because you may have seen the UI, right? Oh, now when you go to even a supermarket, go and have a look at what is their UI. You are IT student, right? So don't just buy things. See what kind of a UI they are working with. Of course, if you go to bank, you will not be able to see the UI, right? They won't show you the UI. But whenever you work with a UI, web or whatever, even a registration form, so as an IT student, you must be curious enough to see how the UI is designed for different functionalities. So this is a very good opportunity for you to see, get a feeling of it. That is why I asked you to develop this and see. Okay. Right. Other forms are straightforward, like spouse, employee, project. This is where you can assign number of hours. Say employee one, project one. You can change the number of hours. Okay. Employee one, project three, number of hours. Okay. And also you can add new records. For example, if I want to add a new employee, sorry, say new employee, there's something called new. Okay. So then you can see. So of course you don't need to add employee ID. Say employee name, say Rohan, say salary is 190,000 and some weird date of birth and maybe department is 2, right? So this is, let's say, yeah, Rohan. So now I can save. So where is the save button? Save button should be somewhere here. Uh, yeah, save. Okay. So when you click save, if you go to the table, employee table, right? Close it and come back. Right? You can see the new record is there. Right? So therefore, this is what your users will be working on. Layer, top layer. This is what we are working on. Right? We are working on. Designers, developers, IT professionals. Internal layer is more for the database management system and database administrators who take backups and so on. Now, is it clear? Is it clear? Right. So let me save this and share you. But I'm putting it to your WhatsApp group, not because you are supposed to open it, right? You are supposed to build it. But in case you have errors or something, you can use this as a reference, okay? But you are supposed to do it by yourself, build this database by yourself. Let me go to codes. A-level ICT 2025. Say new database. I already shared this code. Sorry, not 2025, right? You are 2026. 2026. Still we haven't done any coding, right? Yeah, still we haven't done any coding. This is first one. Yes. Right. So let's create A-level ICT 2026 because now we are starting web programming and so on. Okay. Right. Let's create A-level ICT 26. Let's say 2026. Right. So let's create a folder, database. Say relationships, binary relationships. So if you have access, you can open it also. Right. So let me share that one for you because for the other one, I'm going to use a separate table, separate database. So you need to keep these codes, everything, right? So remember, A-level is a marathon. It's not a 100 meter, right? Now you are in the middle of that marathon, okay? And you need to finish it with good colors, great results, right? So I put it into your WhatsApp group. Right. So now we move on to one-to-one relationships. So far, what we discuss are one to many, sorry, not one to one. So far, what we discuss are binary relationships. So let's discuss about unary relationships. Again, I will start access. So unary relationships are a little bit more tricky. That means it's not impossible, but you need a little bit more seriousness to understand. Because unary means it's a relationship among records of the same table. So far, it is between two tables, right? Employee and department, employee and spouse, employee and project. Okay. But this time it is relationship between instances of the same table. Okay, same table. So let's start with one to many because one to many is always easy. That is why I start with one to many rather than one to one. Okay, so let's remember we discussed about some scenarios. Say one to many of one instance of the table is related to many instances of the same table. But it must not be one to one or many to many. So let's take an example. So employee has only one supervisor. Supervisor is also employee. Employee can have only one supervisor. But one supervisor can supervise many employees. But though I use the word supervisor, supervisor is also employee. So therefore it is one to many. So it's something like supervise. One employee supervise many employees, but one employee is supervised by one employee. employee can't have many supervisors, but supervisor can supervise many employees. But supervisor is also an employee. So it's a one-to-many unary relationship. Another name for unary is recursive. That relationship is to itself, but maybe for two records, right? So how to do that? How to do that? One to many. Now there's no different table, right? So remember, if it is one to many binary, add the foreign key to the many side. If it is one to many unary, add the foreign key there's to the many side, but many side is also the same table. So therefore, still you need to add the foreign key, but there's nothing called many side. Your one side and many side both are the same table. So therefore, anyway, add the foreign key to the table. And then remember, foreign key is mapped to the primary key of the related table. Now, what is the primary key? Primary key is your own primary key because this relationship is to yourself itself. That is why I told you this is a little bit tricky. You need a little bit more seriousness to understand this. Now, a lot of people talk about now why some people like do IT. So some students like to do IT, right? In A level. For example, when I was in even grade 4, 5, grade 4, 5, of course, grade 1, 2, 3, I was not much. So remember, because I can't remember much about what was my thinking at that time. But from grade 4, 5, I want to be engineer. I want to be engineer. I never want to be anyone else. I never want to be a doctor. No, I don't like. I never wanted to be accountant. No, I have never thought of like that. Right? I never ever wanted to get into government jobs. No, no way. Boring for me. But I wanted to be engineer. Okay. So likewise, now if you want to, I don't know, just because you are doing IT, it doesn't mean that you want to get into the IT field, right? Because you have other two subjects also. But if you want to get into the IT field, make sure you have very good logical thinking. Just because you like it, you can't be IT professional. So you must have that capacity, the correct knowledge, develop the skills. Okay. And also you must be able to face challenges. I like facing challenges from my childhood. Facing challenges doesn't mean that physically confronting with others. No. I think I have never ever fight with others in my school. Only one day only I have fight with a student in my entire school life. Only one day. Right? I have never ever fought with any student other than that day. Okay. Because I am not someone who interested in fighting with others. But I like to face challenges. Right? I like to handle complexities. So I like to solve, do mathematical questions because those are so excited, complicated, challenging. It's not boring. Try to understand complex concepts. Likewise, if you are interested, right? So this is a good challenge. Understand how the one-to-one union relationship work, how to design a solution. Okay, right. So now what is your solution? Add the foreign key to the same table because your two tables are the same and map it to the primary key of your same table. Okay, then it is going to be one to many. Okay, so let's do an example. Okay, so let's say we have the employee table and let's create the supervisor one-to-many relationship. Right. So let's save this table. Save, say employee, right? Design view, say employee ID. Let's make it auto number. by default auto number and by default primary key. I'll call this ename, watch, select short text. Uh, of course, if you want, you can add salary and other things, but I'm not interested because I'm more concentrating on creating this relationship rather than attributes. Right. So that is enough for me. Now I have my table. Now I'm going to create that recursive or unary one-to-many relationship. So I must know each employee is supervisor. I must know whether if you are a supervisor, who are the employees you supervise. So it's a unary or recursive one-to-many relationship. So therefore, I need to add the foreign key to this table itself. Remember, when we create foreign keys, we used to give the same name as the primary key of the other table. But unfortunately, now the primary key is in the same table. So therefore, you can't have two fields with same name. So therefore, now I need to break that convention because I have no option. Because if I give my foreign keys name as employee ID, because I'm going to map it to the employee ID, then database will say you can't have two fields with same name. So therefore, I'll call it supervisor ID because it makes sense also, right? Now I'm not going to make it auto number because my primary key is the auto number. Okay, so therefore I'll just make it number. Right. So just because you add a field, still your database access doesn't know that this is your foreign key. Map into itself, right? So therefore now I will close it because you know I am closing this because I want to go to the relationship field. Database tools, relationships, add this. We have only one table. So ideally I should be able to drag this primary key and drop it to the foreign key. Okay. But unfortunately it is not allowed in access. You can see if I click it, don't release it. Now I am supposed to drop it into my foreign key. Foreign key is also the same table, but it doesn't allow me, right? It doesn't allow me. So therefore, what you need to do is there's a small hack. Get the table again. Actually, you are not getting another table. You are just getting the copy of the same table, right? So just think this as again employee. Just it name as employee underscore one, but this is actually the same table, okay? Because this is because of the limitation of my access tool. Now drag this and put it into the other table. Of course, other table means the same table. It's foreign key or the supervisor ID and release it. And enforce referential integrity. Now it has identified as one-to-many. Okay. So don't think that these are two tables. This is just because uh, access has a bit of a limitation in this tool. But you look at it like this. You look at it like this. Okay. Or better, you look at it like this. Okay. It's one-to-many. But anyway, let's keep it like this. But just remember that is what we are doing. Now we have unary one-to-many relationship. So let's add some data also. If you have any questions, you need to ask. Because we are now in the most difficult part of your database topic. This is where you need to understand. SQL is not difficult. Normalizations are not difficult. This is the serious stuff. This is the serious stuff in database subjects. Okay. That is why you need to get it clarified, right? Think about this. So this week is the best week to think about database design because you are fresh. Okay. When the exams are nearing, you are under pressure. Then you can't understand. You can't understand things because you are so worried. When you are relaxed, this is where the best time to think about it. Right. So now I will close it because I want to add some data. Okay. So let's say Nimal. Uh, let's say Nimal is a supervisor. So that means Nimal doesn't have a supervisor. That is fine, right? Because if you are a supervisor, you don't have a supervisor, right? Let's assume Nimal is a supervisor. Say Kamal. Maybe I want to make Kamal supervisor is Nimal. So then I will say supervisor ID is 1. So that means Kamal supervisor is Nimal. And now we know that Nimal supervisor Kamal. Okay. So let's take another one. Say Nimali. Say let's say Nimali supervisor is also Nimal. So that means now Nimal has two employees. Nimal supervises both Kamal and Nimal. Nimal is supervisor is Kamal. Sorry, Nimal. Kamal supervisor is also Nimal. So let's add another employee. Say Rehana. Okay. So let's say Rehana is also supervisor. Can be, right? Maybe Ravi. Say Ravi supervisor is Rehana. So you can see it's one to many. Same person can be supervisor of many people, employees, but one employee can have only one supervisor. And it work. And see whether you can break this by adding data. That means if you can add data so that it is no longer one to many, that means our design is not correct. But I challenge that no, this design is correct. So then if you can show or prove that this is not going to work. So you must have that kind of mindset also. So then you can tell me with some text data. So this is not going to work. Your solution is not going to work for one to many. Then I will again come back to you because I have the confidence with because I have worked with these things in as a software engineer. Otherwise, I will not be engineer, right? If I'm not confident about the consequences of my design. Okay, right. So is it clear how to create one to many relationships? One to many relationships. So that is the beauty of being an engineer, doctor, lawyer. Because when you have in-depth understanding, for ordinary person, it's worried. They are not very sure, but those professionals, they are very sure. Very sure. So I'm very sure about this design. I have no doubt about this because I'm an engineer. For example, when I have a medical issue, I am not a doctor, right? Sometimes I am worried simply because I don't know the theory. So then I go to the doctor. Sometimes simply because I want to clarify my or clear my doubt. So then I go to the doctor and say, I'm worried. So there's a swelling for 3 days. It has not recovered. What is it? So, but doctor knows the subject. Doctor knows the subject. So then doctor might say, okay, let's do a test. Okay, let's treat it. Right? Because he knows the subject, right? He's not worried like me. Sometimes when I am not worried, he is worried because he know that that's a serious issue. Sometimes when I am worried, he is not worried because he know that there's no such this is not no big issue. Sometimes he will say, no, don't worry. Just in 1 week time you will be recovered. Don't worry, just forget about it. So then I also if I because I trust my doctor because he know the subject, right? I am not a doctor. So so therefore when if you want to get into a field, you must build that kind of a confidence. If your field is IT field, when it comes to designing, programming, you must have that kind of a gradually you must get build that kind of a confidence about your design solutions. Okay. Then you can say this is the solution. Don't worry, it's going to work. So what happens if you are developing a software for a bank? So can you say that it might work? No, you must say 100% guaranteed this is perfect solution. Of course, you can't tell like that when you are fresh to the field. That is why you need bit of experience working with some senior people, just like doctors get trained for at least for 5 years. Right? Right. So this is how you model unary one-to-many relationship. And this is your sort of a design. But you can think of it like this, okay? Think of it like this because this is limitation in access. We have to model like this. Unary one-to-many relationship. Any questions? Any doubts? Because now you can have doubts, but not when you become a software engineer. Right? So that is unary one-to-one relationship. Sorry, unary one-to-many relationship. Now I'm going to explain you how to model unary one-to-one relationship. Now you know what is unary one-to-one relationship, right? So we have a table and there's a relationship one-to-one and the relationship is to itself. Not like this. This is binary one-to-one, like employee and spouse. Employee is one thing, spouse is another thing, but this is unary one-to-one. So can you tell me an example? I think maybe I have given you some examples also, right? Because we discussed this in analysis. So what is the example we took? Say student is partnered with another student, like Montessori classes. So say Nimali's partner is Tamara. So you must always work together, right? Kapila's partner is Vico. So you අර කියන අත්අල්ලගෙන එහෙම යන්න කියලා ට්‍රිප් එකක් ගියාම එනකන් ඔය දෙන්න තමයි එකට ඉන්න ඕන. So you can't partner with multiple people. You can't change your partner until you come back. One-to-one relationship. Likewise, think about things, practical things that you see in your schools, in businesses, in your day-to-day environment. Okay. Like one vehicle, one chassis, one engine. So you don't change your engine time to time. Of course, if you do it, then again make sure it's bound to one at a time, only one vehicle. But not like a aeroplane where you can have two engines. Okay, but this is but that is not unary one-to-one, right? That is one-to-one. But what we need is unary one-to-one. Right. So let's model this one. Right. But these are isolated examples, right? In the previous one, we had a combined example, employee, department, project, but these are isolated examples. Okay. Right. So let's create student. Create a table, save student. Let's go to the design view so that we can add some fields. Say student ID. Say S name. You know that name is a keyword. Yeah, maybe that's enough. Yes, I want to explain you the relationship, right? Not about attributes. Let's keep it simple. But now we are going to create a relationship, right? So how to make it? So now we are going to add another foreign key. So remember we have the student ID, name, OS name. So our foreign key is going to be added to the same table because this relationship is with the same. So let's call it partner ID or whatever, because student ID you can't use. Then you must say student ID one, student ID. Let's say partner ID, which is our foreign key. So then it is related. But if you just create like this, it will be one to many. Remember, this is how you create our employee supervisor. So this is going to be one to many. So that one student will have many partners. But we want to restrict so that a particular partner ID must be used only once in your table. That means that partner is only for one student. Earlier, this was repeated. That is why same different employees had the same supervisor ID. But this time we want to restrict. How to make it? Make this unique, no duplicate. Add your foreign key and make it no duplicate. Simple, same solution, right? Even in binary, we use the same solution, right? So nothing, right? So let's say partner ID, a number because we are going to map it to our own primary key, but make sure it is unique, right? Index, yes, no duplicate. Yes, but no duplicate. So that will make it one to one. We can double check in the relation design view. Right, now we are done. Save. Let's go to the database tools. Now we have the student. Let's edit. Remember, we are going to do a unit relationship. Therefore, we need to edit twice because I can't just drag and drop it here. It is not accepting, unfortunately, right? So therefore, I'll again edit. That is copy of that. Remember, now we have already made this partner ID for a unique field, right? So therefore, it must detect it as one-to-one. Here, it detect it as one-to-many. So let's drag and drop. Say student ID, drag, release to the partner ID. Actually, I'm releasing to the same table, just a copy of the same table, okay? And say enforce referential indicative. Already it has identified that one-to-one because I made it unique field. You can see one-to-one. Can you read it? One-to-one. Earlier it was one-to-many. That is because I have already made it because we are doing it according to theory, relational theory. Right. So let's say create. Right. You learn, you remember, you look at it like this. So you look at it like this. But because of that restriction, we need to show it like this. Right. Told limitation in our tool. This is one-to-one unit relationship or one-to-one recursive relationship. So let's close it so that we can add some data. Right. So student, I'll call Nimal. Say Nimal, I will just keep the partner ID empty for the time being because still we have only one student. Let's say Nimali. I will say Nimali's partner is Nimal. So then I will say Nimal's partner is Nimali. That of course we need to be disciplined when we enter data. Otherwise it will really mess it. But now let's have another, say Kamal. I will just keep it empty the first time being. Say, let's say Kamala. I'm just using the same name just to map it easily, okay? So let's say this is Kamal is the partner. Kamal's partner is Kamala. 4. Okay. So now I can say, now I can say. But now when I say I can't have the same, for example, here I can save as 201 because this is unique field. Then it is not one to one. For example, if I save it like 2, now I can't save it. Error. Because this is one to one. How to make it one to one? We have made this unique. So therefore, I can have this something like 3, but again, you can't use through 3 anymore. This is the only place you can use 3 because it's one to one. It's unary one to one. So only difference is I made I made this field unique field. But here I did not make this field unique. I just make it foreign key, but this foreign key, before making it foreign key, I make it unique because I wanted to make it one to one. Right now we have unary one to many, unary one to one. Any question? Any question? Any question? Because after design is over, two-third of your database topic is over. Then we have the SQL. But design we are not going to finish it today. Design we are going to finish only in the next class because we need to do normalization also. Normalization is the second part of design. Just give me 1 minute. Right. So, so any questions? Any questions? No? Right. So then we'll move on to our third. Now you know what is the third scenario, right? Third scenario is many to many, unary many to many. And this is the trickiest. This is the trickiest because now we are going to have unary relationship, but it is many to many. First of all, you need to identify a common scenario, practical scenario. Then only we can think about the solution, right? Now we can actually guess what is the solution is. What is the solution is. If if you can see the patterns now, actually you can guess what can be the possible solution. But don't worry, I will tell you the solution because. But first, let's see practical scenario like this. Anyone tell me a practical example for unary many to many? Unary many to many. These are very rare, but there are some scenarios. So the best example I can tell you is from IT field, not IT field, like uh, information systems, like social media, like Facebook, Instagram. So if you take something like Facebook, you can have friends. Now here we restricted friendship. You can have only one partner and that partner has only one partner. But in Facebook, you can have many friends. And those friends can also have many friends. So there's no restriction, right? So for example, you can have hundreds of friends in your Facebook. And those friends also have not only you are the friend, you are not the only friend of those, they also have hundreds of their own friends. So it's a particular member can have friendship with other members. One member can have many friendship. Other side also one member can have many friendship. So one entity related with many and also one related with many, both side many. And that is a many-to-many relationship. Okay. That is a many-to-many relationship. So let's model that. Okay. Right. So let's create member or something. Okay. Say member, user, or whatever. Let's first create the table. Create table. I'll call it member, user, whatever. Okay. Right. So let's have few fields. Say member ID. Say name, member name. Uh, Now we want to create the relationship. Remember, member can have. Okay, let's add some data. Say Nimal, Amal, Kamal. I'm using these simple names, okay, because it's easy to type. Ravi, Rizvi, Raju. I'm adding few more because there's possibility of many to many friendships. Okay. Okay. So let's. Right. So now I want that many to many. Remember, when we have many to many, that is always challenging, right? So there's only solution is introduce another table. So this is our original table member. So now we need to have many to many. So the solution is now you know, right? Introduce another table and model it as to one to many relationship. And many side is your connecting table. So this is not a new solution. This is the same solution applied to the unary. right? And now you have the two foreign keys, one for this, one for this. And both foreign keys are referring to the same primary key, member ID. Two foreign keys referring to the same primary key because this is just a connecting table. So I told you this is the hardest to understand. You need to be serious. So if you are serious, you will understand. If you are not that serious, you will not that understand. Right? Your understanding will be a little bit lacking. So that is how some people get A's, some people get B's. So that is a natural phenomenon. So I always ask you to get a good results, right? I am not asking every one of you to get A's. That is not my task. Right? So that is how our class is different from other classes. My task is not make everyone get A's. My task is teach everyone the best I can. And if you are good enough, get a A. Right? If you're not good enough, maybe get a B. That is fine. That is your capacity. But make sure you keep asking questions, understand, spend some serious time. That is your task. Because without that, you will not be able to get a A, B for this subject. Okay. Because this is not something you memorize and pass. Okay. Right. So therefore, now our solution is introduce another table and build it as to one-to-many relationship. So therefore, we are going to have two foreign keys, and that combined foreign key we are going to make our primary key. Right. Combined primary. Right. So let's add our connecting table. Now, when it comes to binary, I use the two tables names, right? Employee project. Here, then can be member. Or we can give it a meaningful name rather than member underscore member, whatever. I'll call it friendship just to make it more meaningful. Okay. Right. Create this our connecting table. I just call it friendship. Or you can say member. Okay. Right. So now I will go to the design view. And let's say now you need to add the two foreign keys. So remember, it must be member ID, but I can't have two fields with the same ID because we are going to create two relationships to the same table. So therefore, I call it member ID 1, member ID 2. Okay, member ID 1, but don't make it auto number because this is our foreign key, just number. And member ID 2, let's make it number again because we are going to map it to our primary key, which is uh, member ID in the member table. This is not member table. This is our new connecting table. I call it friendship. Right? And let's combine these two fields and make up a primary key. Right? Because I selected both. Sorry, I want to select both. Control and don't release the control and right click and say primary key. Now this combination is our primary key. If you need any other field, you can add. So that means if you have, remember when it comes to many to many, there's a possibility of attributes here. We can have attributes here, and there's a possibility of attributes here because those attributes are related to this friendship, not directly related to a member. So now think about what are the possible attributes which is related to this many-to-many relationship. If you think really hard, even you can think some possible attributes. For example, in Facebook, there's a concept called close friends, not very close friends. So if you mark it as a close friend, you will see more posts from that friend. And also, so that friendship type that is not visible to your other friend, but that is visible to you because you said it. Friendship type. Maybe date of friendship. Where did you send your request and the other guy accepted it? So that means you have been friends in the Facebook, those two guys, from that particular date because you get friendship with others in different dates. Okay. So Senimal get the friendship with Kamal on January 2nd. Nimal get the friendship with Nimali, maybe February 10th. So that is, you can't put it into the member table because it's related to your friendship. So let's add something like that to make it a little bit more interesting. Right? Let's say date of friendship. Date of friendship or friendship start. Let's make it date, right? Date time. And that's a normal field. Now I have the connecting table with some meaningful field also just to make it more interesting, practical. Now I'll close this. I'll go to my database tools, relationships. Now I want to add member and friendship. Okay. Let's first add member. Now these are three isolated examples. Okay. These are not like our first example and maybe friendship. Right. So now I can create the first foreign key, primary key, drag and drop to member ID 1. That is my first foreign key. Release, enforce referential indicate, that is first one-to-many relationship. And I can drag and drop to the member ID 2. That is for the second relationship because friendship is between two friends. Now it says it's already there. So that is again restriction or the limitation in my access. Ideally, I should be able to create another relationship like this. Okay. But this is because this tool actually still I can remember about 15 years ago also I use access. The UI was like this. So it has not been changed for last 15 years. Okay. So therefore, these tools have a bit of limitations, but there's a workaround for that. That is just get this friendship table again. It's copy because this is not allowed by tool. Okay. Allowed by tool, unfortunately. So therefore, anyway, there's a workaround. So get the friendship table again and get the friendship table again. That means it's a copy. It's a copy. And then add it your second relationship to the member ID 2. Right. Now you are done. Enforced referential indicate. But you read it something like this. Something like this. Okay. Just because of the limitation in this tool, I have to show it like this. But you read it like this. Okay. Two one-to-many relationships. Because this is the same table. Okay. Same table. Right now you're done. So that is also done. So I'll close it. Yes. So let's add some data. I have some members, but now I want to add some friendships. Okay. Just give me 1 minute. Right. Sorry about that. So now let's add some friendship. Say member 1 has a friendship with member 3. Right. So similarly, when I can say member 1 has friendship with member 5. Okay. So I can say member 4 has friendship with member 5 also. That is 5. Maybe member 4 has friendship with member 3 also. Right. Member 3 also. Right. So likewise, I can add because one person can have many friends. One person can have many friends. And that friend can also have many friends. So I can say member 5 has friendship with member 1, but don't add 1 tree again because that friendship already we have recorded. For example, if Nimali is already friend with Nimali, so you can't again send a friend request and say I'm again getting friendship. Of course, if your friendship is uh, Unfriend, you can again friend. That is a different story, but we are just showing the current friendships. Right? So this is many to many. This is many to many. So look at this and make sure you look at this something like this. Something like this. So why I have got this one twice? I think this is by mistake. It has added twice. Yeah, so this should be deleted. Okay. Right. So now it is fine. Okay. Now it is fine. Anyway, I will show it like this. Right. So any questions? So this is unary one-to-one. You read it like this. Okay. So unary one-to-many. This is unary one-to-one. You read it like this. And this is the connecting table of unary one-to-many. You read it like this. Okay, you read it like this, but I just keep it like this, okay? Otherwise you will get confused. Right. Any questions? Any questions? So we did a lot of things today. Binary one to many, binary one to one, binary many to many using connecting table, then unary one to many, unary one to one, and unary many to many using connecting table. Any questions? Anything that you want? And make sure you take quality time about 3-4 hours and do these design by yourself. Sit in front of your computer, open your access, and do this one by one. Maybe occasionally you can refer to the recordings, you can refer to the note, but do this as a practical. If you want, okay. If you don't want to do it as a practical, that is fine. That is your choice. So maybe you don't want to be serious. So that is fine. So then you can also get a non-serious job. That is your choice. I'm not saying that non-serious jobs are bad. That is also good because we need that kind of people, that kind of services. Maybe you also like to be a little bit more relaxed. You don't want to take a lot of responsibility, so that is fine. Because we need different type of people in this society, right? Right. So now we are into the last concept, that is ternary relationships. Remember, ternary relationship means between three tables or three relationships. So there's a relationship between not one, not two, it's three. I told you these are rare but possible. Possible. And we discuss some examples, right? We discuss some examples. So what is the example we discussed? Product, brand, say warehouse. Say how many Singer TV in Colombo branch? How many? Now we are going to do it in a practical manner. There we just thought about it. Yes, that possibility is there, but now we are going to develop it. Make a solution to when we have that kind of a situation. Because ultimately you need to provide solutions. Okay. And you can think of another Turner relationship and you can create tables for that and see by entering data, is it going to solve my problem, my design? Does my design work? Right. So let's do it for this example. I'm going to use the same database because now this database has the unary and ternary. Other database has binary. Okay. Right. So now I need three tables now. Let's quickly add, say first one, product. product. This is not difficult actually. Product. Let's save it. Design view. Say product ID. I will add the minimum number of fields because I'm more interested in relationship than adding so many fields, right? Say I'll keep the auto number, that is fine, but I'll just add one more field. Let's call it P name, product name. Right? Maybe short text. So I'm happy with that. Let's add some data also. Say I'll just call it product one, product two, and maybe product three. Right, so that is my product table. Now I will add my brand table. And add some meaningful fields. Say brand ID, auto number, primary key, maybe B name, brand name, short text. I will add some data. I will keep it very simple. Few data, maybe brand one, brand two. Right. So now my final table, of course, we need to add a connecting table later. Let's call it location. Okay. Or warehouse or stores. Okay, let's say stores. Stores. Again, I want to add some meaningful fields. Say store ID, primary key, and store name is name. Right. Just keep it simple, okay? Right. So now I have three tables. Okay, let's add some data. Say store one, store two, maybe store two, three. Right. So now I have data also. Now we have the three tables. Now we have the three tables. Now we want to create this relationship. So how to create a relationship? Introduce another connecting table and create three relationships. Usually these are one-to-one relationships. And that effectively create this Turner relationship. So that is the solution. I told you that solution is not difficult. It's like the solution for the many-to-many binary. Okay. Because these are often many-to-many anyway. Okay. So make sure then you have four foreign keys because this is your many side. Four foreign keys. And that combination of the three fields, you make it your primary key. It's a composite primary key combining three fields. And you have three foreign keys. And this is the ultimate complexity that you need to understand. Right? Don't worry. We don't go for any complicated scenarios than this. This is the ultimate complexity. Ternary relationship in your A-level ICT syllabus. Even in degree level, this is the level. Right? We don't go to anything else. If you can do this, actually you can even do a degree level. You can go and survive if you understand this. Because your A-level syllabus is pretty much closer to the degree level syllabus, at least semester level one, year one, which is good. Right. So now let's add our connecting table because we have the three tables. So let's add our connecting table. Uh, you need to give a proper name, but you can connect the three tables, right? Product underscore store underscore brand. Or you can just give any other meaningful name. I like to give the combination of the three table names. Product underscore brand underscore store, store. Okay. So then you know that it's probably a ternary connecting table for ternary relationship. Right. So let's add the fields. Design view. Sorry, not stores. This one. Right. So let's say product ID. Now you don't go for tour number because these are three foreign keys, just number. Brand ID, another number field, and stores ID. Store ID, another number field. And if you have any meaningful fields, that is fields for the relationship, this is the place to put it. Maybe number of items. So that means say product one, brand one, in store one. How many items are there? So how many single TVs are in Colombo branch? How many single washing machines are in Colombo branch? So let's say number of items. So, okay, number of items, just to make it a little bit more practical. And that also number, but that is not going to be my foreign key. Right? Right. So now I'm done. Now I want to create my three relationships. Right? Three relationships. So go to the database tools, relationships. So it's like a Thoran name. That's fine. If you are doing IT, you must be able to handle complexity, right? Right. So now I have the three tables: product, uh, brand, and stores. And then my connecting table, that is product, brand, store. Now you know what to do. I have, okay, so I have not make my foreign key. You can see this is just, this one is a primary key. This three combination of these three must be primary key. So therefore I'll close this. Yes, save it. I want to make that and come back. Okay, because I have not make my primary key. Remember, still my primary key is only product ID. But primary key must be a combination of these three. I will use the control key, right? Select one, control this, don't release control, right click, primary key. And now it's a composite primary key. Right, now close it, save it. Now let's get back. Now you can see it's composite primary key. Now I can create the three relationship. Now it's very easy. Now you know what to do. Take the product ID, release it under product ID field, enforce referential integrity, that is one to many. Brand ID, release it under brand ID. Store ID, release it under store ID. Right. So now we have the solution. So how to build ternary relationship? Introduce a connecting table, just like binary many to many. Right. Done. Now let's close it and add some data. So let's go to our, because we have already entered data for the product. We have entered data for the stores. We have entered data for the brand. So let's add some data for this. Say product one, sorry, okay. Say product one, brand one, in store one, how many? Let's say 12. Say product one, say like Singer washing machine. Product two, say product one, brand two, in say store one. So there are five elements, five items. So, okay. So let's say same product one, brand two, again same brand, but say same brand and same product, but this time in store two, different store. So let's say we have eight. Now you can see. But this combination can't be duplicated. Right? Say product two, brand two, store three, say you have 12. Say product two, say brand two, right? brand 2, and store 3. Sorry, store 3 already there. Say store 1. We have 2 items. And so now we are done. Now we can track for a particular product from a particular brand in a particular store, how many items are there. From the head office, you know this much of items are there in that particular store, on that product, that brand. So that is how you come up with a solution for your ternary relationship. So at first it might be impossible, right? But that is what engineers do. That is what scientists do. That is what we do, right? So we can come up with solutions. So engineers' task is solve problems, come up with practical solutions. So that is how, for example, when I did my A level, right? When I did my A level, there was no internet, right? There was no student management systems. There was no online education classes. But now we have. We do e-banking, student registration systems, inventory management systems. So when I did my A level, when I go to the shop, there was no shopping supermarkets. So that Mudalali used to do the calculation and give the balance, but it is no longer the case, right? So because we have these databases, programs, software, web applications, right? So that's it about. So now we have covered up to this point, right? Up to this point. So binary. Now go through the note again. Okay, go through the note again. Binary one to many, binary one to one. So this exacts. So here we use employee and locker. That means employee has one locker is assigned to one employee, right? So likewise, you can think of different problems because in the exams they are going to give a different problem, right? So this is the second solution, same primary key. And this is the solution I implemented, having the foreign key and make it unique, just to make it one to one. Then many to many. So this is student can go for many courses, course can have many students, but I implemented employee and project, right? So then unary one to one. So we did the same thing. Unary one to many, right? So this is friendship, sorry, partner, unary one to one, and unary many to many. That is what we discuss, right? Friendship. And mapping ternary relationship, we did the exact in product, brand, store, and we add this into our connecting table, right? Right. So next class, we are going to look at how to model bit of weak entities. Okay. And also some more integrity constraint. Actually, we have already discussed, right? Referential integrity constraint, but we are going to formally looking at those things. Okay. And mapping inheritance. So remember we discussed about overlapping inheritance and disjoint and also show total versus partial. So how to model that? So then design part is over. Design part is over. So this is our fourth class, right? Yeah, fourth class. So the fifth class design is over. So then we need 3 more classes to do it. SQL, then database subject is over. Okay. And we stop at this point, right? Thank you.